Hi, hello everyone. I'm Jenny Mallette. I'm a machine learning engineer at IBM. I think I actually have a slide on that later, so I won't say too much. But this is a workshop called Introduction to Python, just meant to teach you sort of the fundamentals of coding in Python, coding in general. And it's meant to be kind of interactive. We've got some exercises. I posted a couple of things on the workshop Slack channel. So you can take a look at installing Python there and download some of the exercises. So with that, I will get started. All right, so like I said, I'm Jenny Mallette, machine learning engineer at IBM. My team is called the Unified Messaging Experience Team. And that just means that we support chat on IBM.com web pages. Every time I say chat, people think like, oh no, are you looking at my company messages or something? No, that's not it. It's for when customers want to reach out to representatives on IBM web pages. And we're not the people answering that, we're the people that support the feature that allows you to do that. As a machine learning engineer, I actually work with leveraging the data that we get from those conversations, the chat transcripts. And one of the biggest things we do is we build chatbots for that. So I've actually linked, and I'll post the slides later, but I linked one of the pages that has one of our chatbots. Feel free to go play with it. I also linked a poster that I presented at Grace Hopper this year. I'm not sure if you guys are familiar with Grace Hopper, largest women in tech conference, highly recommend looking into it. But it goes into some of the more in-depth analysis that I've done with the machine learning on the chat transcripts. So just thought that would be cool. I don't know how much longer they're gonna leave it up there for, but check it out while you can. I got my bachelor's and my master's actually from Cornell, just like 4 years ago. So not too much older, not too much in the workforce, but I've been here for a little bit. And I'm working in New York City, usually living in New York City, but I'm back home in Vienna, Virginia for the holidays, where I've actually spent a good portion of this year as well. All right, so if you haven't installed Python yet, don't worry, it's pretty easy. First step is making sure that you do have it installed. Like I said, the instructions for doing such, I posted in a Word document that should be available on the Slack channel. I think they were pretty clear, but if you want to check and see if you have it installed, first step is to open up your terminal if you're on a Mac, or command prompt if you're on Windows, and then just type in Python and press enter. So I'll actually do that right now so we can, like I said, be interactive here. So I've got terminal open. If you've never done this before, totally fine. Very easy to search for. Command space is how you can search for something on Mac. There it is. That's how I would open it. And Windows should have like a search bar in the lower left-hand corner where you should be able to type in command prompt. That's with the space to open this up. To see if you have Python installed, simply just type in Python, press enter. If you do have it installed, you'll see Python sort of open up this interpreter here with a version number. Just note that because there's a few things with that later. But this is what happens if you do have it installed. If you don't have it installed, there's like a few different behavioral things that might happen. You might get an error message saying that the word Python isn't recognized. Or as I've learned on Windows 10, it actually opens up the Microsoft Store and gives you the option to install Python. So very easy to install from there. But if you would prefer to go to the website, I've included the link on the slide here. It should provide you with the automatic option to just download the correct version. Do all the default settings, pretty easy. And I've also, because we'll be using VS Code today, I think you've done things in VS Code before, but if not, I've included the link to download that. Again, should be a pretty simple download, install, default settings should be fine. All right, let's go back to this. Ooh. I haven't talked to people in a long time. All right, so in the setup, I asked you to note the version of Python that you had. Python 3 is actually the latest version, and it's the version that we'll be using today. But if you have Python 2, don't worry. I don't think there's too many differences between what we'll be doing today that it interprets differently, but there can be differences. And if you're using Python 2, you definitely want to use 2.7 or higher. Note that it's sometimes accessible with the command Python 2 instead. So if you want to have both Python 2 and Python 3 installed, you might be able to reference them by specifying the version afterwards. But like I said, we'll be using Python 3. Always best idea to use the latest versions of things, although I kind of miss and love Python 2 myself. So if you are in that group, you are not alone. All right, so Python requires both a text editor and a tool to execute the code when programming. And that's because when programming, we typically write the code we want to execute in a file, and then we run that entire file. So we'll be using VS Code as an IDE to do this today, which simply allows you to have both the terminal that you will execute open with the text editor that you'll be writing in. Python also has this interpreter, which is what popped up before when you typed in Python to see if you had it installed, only if you did have it installed. And you can either use that in the terminal that we'll be opening in VS Code in just a minute, or in your terminal / command prompt that we were just playing with. So like I said, I can show you that really fast. So if you did type it in and this happened, then you're in the Python interpreter. Congratulations. You can start doing some Python commands in here. We'll get to like some of the more fundamentals in a minute, but I'm just gonna like set this string XABC. It runs line per line. So it will run each individual line of Python code. And it's a really cool way to sort of play around with things in Python if you want to get comfortable with it. So I'm just going to like do a print statement. I see it's returned here. I can play around with like some math, like I could do 4 plus, I don't know, 80. Probably didn't need to do that in Python, but you can do pretty much anything you'd want to in the interpreter. And it's really just a fun interactive way to get to know Python. To exit the interpreter, because note that this is different than, you know, your bash or DOS profile that you had open before, because it's interpreting Python code instead of what's up there. Like if I were to type in Python, it wouldn't be recognized. To get back to where you were before, you just simply type in quit, open parenthesis, close parenthesis, press enter, and we're back to where we started. All right, back to the slides. Okay, actually, I'm going to switch back to VS Code, but just some quick notes about it. It's a popular integrated development environment, also known as an IDE, allows you to have those files of written code in the terminal open at the same time. And one of the cool things is it will frequently identify what language you're writing in based on the file extension name, and can kind of highlight some keywords for you. So you know if you've like made a syntax error or whatever, or even underline something in red if you've messed up to let you know, hey, this isn't going to run before you run it, which is really cool. So like I said, I sent a zip folder in the workshops Slack channel before. So I'm just going to download that myself and open it in VS Code. I was always terrible at sort of finding things and getting an environment set up, which is why I kind of want to step through when I was learning programming. But I've got it downloaded. It's going to be in your downloads folder, so that's what I'm going to open. But first I'm going to open up Visual Studio Code. It's being slow today. Oh, this is some work stuff. Didn't think that was going to happen. Thought it would just give me a new window. All right. New window, Visual Studio Code. I believe this is what you should see no matter what operating system you're working on. I want to open that folder that I just downloaded. Actually, I want to make sure that that's unzipped first. I think my laptop automatically does that, but nope. We see the zip. Just going to click on it and that should do it for me. I'm pretty sure you guys know how to unzip folders, so I won't go through that. All right, we see that's in my downloads folder, so I'm just going to open that in Visual Studio Code. File open in my downloads folder, convenient. And I'm going to open that entire folder. I've actually provided you guys with the solutions to the exercises that we're going to do, but I'm also going to walk through them, obviously. So that's here. So we've got this exercises file. We see this file, like I said, is where we'll be coding. That's sort of the text editor portion. And I see a note here. Are people still downloading things? Because I can slow down. I will wait a minute for everyone to get some things open just to make sure that we're able to follow. We're actually not going to use this right away. We're going to go through some like more fundamental concepts before we dive into using it. But I will say, like I said, getting everything set up can be a little confusing. So if you totally miss that part, I can understand being a little lost and having the entire thing open. If you missed what I said before, once you have Visual Studio Code open, just being able to go File, Open, and navigating to that Python workshop folder that we had before should open the entire environment in here. And I forgot Python installation can take a couple minutes, even though it really is easy as well. Haven't had to install it myself in a bit. Okay. All right, so now, assuming that you've been able to open up the Python workshop folder in Visual Studio Code, I want to be able to open the terminal so I can see where I'm executing the code in the same environment. So I believe if I go to View, there's an option for an integrated terminal here, which is what I want to open. And that will take a minute as well. But we see that once that opens, it's a very similar thing to what I had in my command prompt. I can actually type in Python just like I did before, same thing opens, and I'm able to do those Python commands that I had from before and exit that environment. I did mention that, we're writing the code up here in this file, and then we'll be running it here in the command prompt. You can do that in the interactive format, but you can also run the entire file at once. And the way that you do that, and we'll do this a couple of other times as we're doing the exercises, but you type in Python and then just your file name. And it's important to make sure that you're doing that in the same location that that file is in, because I don't have any other folders here. This is the main location. I'm in my Python workshop folder. But I just want to run, and there's no code in this, so nothing should happen. I just want to run the exercises file, exercises.py. So I do have to include the py extension here, Python space exercises.py, press enter, and it runs that whole file. Like I said, no code in it right now, so it didn't actually do anything. It didn't actually print anything, but we'll be changing that in just a minute. Okay, so now we're ready to program in Python. So let's get back to the fundamentals. All right, moving on to strings and variables. Let's start with variables. Variables are storage locations that have names. So anything that I want to store, reference, and potentially change, I will store in a variable. Here, I'm storing the word apple in this variable named fruit, and the number 2 in this variable named x. And when I print out, we will get to the print statement later, I promise, but when I print out that variable fruit, it actually prints the word apple that I stored in that variable. A couple of notes about valid variable names in Python. Variable names are case sensitive. So if I had made the variable fruit before with a capital F, it would be different from the variable fruit with the lowercase f in that previous example. They always have to start with a letter, but they can contain a number, and they can also contain underscores. So I could have fruit 1, fruit 2, fruit 3, all valid variable names. I could have fruit underscore 1, underscore 2, underscore 3 as well. But there are certain characters that aren't allowed, like the plus sign, a comma, a minus sign, and that's just a few. But you will frequently see underscores and numbers in variable names. It just cannot start with a number. So strings are a data type that represent text. It's a collection of characters that are surrounded by single or double quotes. And in Python, you can use either single quotes or double quotes in order to make a string. But you have to be consistent. So if you start a string with one quote, you have to end in the same type of quote. And I said in Python, you can do single or double quotes because a lot of other languages might only be one or the other, but Python is cool because it does both. So here I have the example fruit, making it the word apple, just surrounded by single quotes. Fruit, also making it the word apple, surrounded by double quotes. This is essentially the same code right here. I'm setting both of these things to the same variable, and these are literally considered the same string, despite the fact that they're being defined differently with the single quotes versus the double quotes. Sometimes you want to use a quotation mark that you defined your string with as part of that string. And you can't simply use that exact quote in the string, as it will cause Python to interpret it different syntactically. So in order to use a double quote in a string that we have defined in double quotes, we use what's called an escape character. And oops. So an escape character, the escape character in Python is a backslash, as shown in this example. We put it before the offending character, or the character that we're worried that Python will interpret differently, to say this is part of the string. And there's other special characters that also require this escape character, but we won't get to those today. So I see in my example, when I actually print out this variable that I've set that contains double quotes inside it using the escape character to define those double quotes, it prints out apple with the quotes around it, as those quotes are now part of that string. Okay, so now I'm going to go into indexing a little, which is a pretty important concept in Python and many other languages. Each character in a string has an associated index that reference its position in the string. In our string apple, these are the associated index numbers here. And note that Python's indexes actually start at 0. Other languages have a similar concept, but they might start at 1. So A is actually the index 0. It's the 0th element of the string. To index the string, using index as a verb now, we use the notation here. We're able to say, I want the third character, or the character with index 3 in the string. And we just take the string and simply have the number that we want enclosed in brackets. And in this first example, print apple index to 3, we see that that's the L, because L is at the position 3 for the string. We can also do this for ranges, so it doesn't just have to be one character. I can say I want 0 through 2, and we simply separate those with a colon syntactically in Python. But note that the final number is not included. So it counts 0, it counts 1, it does not count 2. When you're saying like this through that, it's really everything up to that, not including that. So if I were to say 0 through 4, we'd actually only see A, P, P, L printed. Okay, so now I want to mention some built-in functions for Python. The most important one, which I've already used a few times in this workshop, is called print. It simply will display whatever you're printing on the screen in your interpreter, wherever you're running your code. In Python, the print syntax is really simple, just the word print with whatever you're printing in parentheses. So when I print hello world, we would see hello world displayed. The second function that I want to mention is the length function. This will give you the length of the string. And note that we can actually nest these functions. So if I wanted to print the length of the string, I can just put that function inside this other function, and it will give us that value. And an important thing to note here is that the length string gives you the total number of characters in the string. So while before, just let me go back. While before we saw that the final character in apple had the index of 4, the length is still 5, as that represents the total number of characters in the string. Okay, so I have like a slide here on basic object-oriented programming. Object-oriented programming is a specific type of programming where you define everything as objects and their types, and you make new types defined as classes. It can get pretty complex. I've taken full year-long courses on this, so we're not going to go too in-depth for it today. But the important thing to note is that everything in Python is an object, and every object has a type. So when we were playing around with Apple before, Apple is of type string, or we might call that a string object. And the real main reason that I'm mentioning that to you is because I want to introduce some methods that we could apply to some string objects, and the fact that those have a different syntax than when you're applying a function to those objects. So the syntax for applying a method to an object is to do that object dot method. And the method will always have open and closed parentheses. Sometimes you put an input in there. Sometimes they don't require an input, so you leave them empty. So there is one specific method that I wanted to introduce, and that is the lower method. So the lower method is a specific string method that will return a string converting everything to lowercase. So we see in our example here, I've set the variable fruit equal to apple with a capital A, and then I print out fruit.lower. And that takes in the string apple and it converts everything to lowercase. So it prints out the lowercase a despite the fact that we defined it with an uppercase a. But it's important to note that this is returning a new value. It's returning something different. So it's not actually changing the original value of what we put into fruit. There are some functions that do this. I'm just specifying that this particular method does not. And we'll see that fruit remains the same with the capital A here because the lower method returns a new object. Okay. So this is the last topic for strings, and then we'll move on to some fun little exercises. Concatenating strings is when you want to combine them. So if you have multiple different strings and you want to make them one big string, how would you combine them? Syntax in Python is really easy. You just use a plus sign like you would with numbers. So I have 3 separate strings here. I love Python. And note that I've added in spaces because a lot of people forget this. It doesn't know to add in spaces for different words. You have to specify that there should be a space in between I and love, space in between love and Python. I actually made a mistake when making this slide. I added in the space twice. So we see there is a space after love and a space before Python, which is why there are 2 spaces in between here. And with that, I think it's time to do some exercises for the strings and variables. So I'm going to switch back over to VS Code. So many Zoom things in the way now. All right. So if you're able to open up the folder that was posted in Visual Studio Code, the exercises.py file, you can open up here. And I've just got, I think, numbered 1 through 16, some things. We're just going to do the strings and variables section right now. I've written everything in comments, which is actually a concept I haven't introduced yet. A comment is just like a non-code note in the code. So if you want to make a note of something, that's what a comment is, and Python will just skip it. It won't try to interpret it. And the syntax for that in Python is just to use the number sign, typically for like a 1-line comment. But there's also the ability to do multi-line comments, and I should have done a better example of that there. So if you do 3 open quotes and 3 closed quotes, and that can be either single or double quotes, you can write a comment on multiple lines. And that's typically used for making what's called doc strings for functions, kind of just an explanation of what the function does whenever you write it. We are getting to functions later. That's why I didn't want to go into it right now. But just so you know, that's when people typically use this triple quote method of writing a comment. So first exercise, hopefully you've got it all open and running and working now, is to write a program that prints hello world. This should just be a 1-liner, but I'll give everyone a minute to do such, and then I will do it myself. All right, so I am going to take a crack at this one. Remember our print function is just the word print, and then we put whatever we want to print in parentheses following it. Because we want to print the string hello world, I'm just going to put that string right here, print hello world, and that should display the value hello world. Like I said before, we can execute this code by running it in the terminal. I showed you before that we can say Python exercises.py, and that will run this file. And because this is now a line of code that we have where it's supposed to display the value hello world, if we run that again, so Python exercises.py, and just a quick note, if you press the up arrow in the terminal, it will automatically fill the next line with whatever you had in previously. That's what I just did. That's why you didn't see me typing it all out. So I'm going to run that. And we see that hello world, move my chat out of the way, hello world is displayed here in the terminal. So with that, let's move on to the second exercise. If not done previously, edit this program, this line, to store the string hello world as a variable and print that variable instead. So I'll just give everyone a minute to do such. Okay, in the interest of time, I'm going to move on because I think the next exercise kind of spoils this one a little bit. But I'm going to call my variable x, and I'm just going to put hello world and store it in that value x. Then instead of printing out hello world, I'm going to print x here. And actually, I just want to note something that I just did by default, something my motor skills have taught me to do. I always save after writing a few lines of code, saving my file. For me, I'm on a Mac that the shortcut to do such is Command S. You can do such with Control S if you are on Windows, or you can go File, Save. But most programmers kind of just do it by default on the keyboard because it's easy. But you will see that if I make changes, in VS Code, there's a little dot here, so that can tell you that you haven't saved your code before running it. But you must save your file before running it, otherwise you will not see those updates when you do run it. So I'm going to save. And then now I'm going to run it again, and we should actually see hello world displayed twice because it will still be running this line up here, and then it will be printing it down here. And there it is, displayed twice. So moving on to the third exercise, I've added in some code here because I wanted us to get comfortable with indexing, and I wasn't sure how else to do that without providing a string that we wanted to index. So I've asked to uncomment the code below, which is to just remove these number signs that are in front of it, and to change the code to only print hello world. So I've got this string in this line, which I've set to the variable x. And it's hello world that is preceded by 2 dashes and followed by 2 dashes. And I don't want those dashes to show up in my print statement. So I'm going to do something to x in this print statement in order to index it. And I'll give people a minute to figure that one out. So I'm going to jump into the solution in the interest of time. Remember the indexing we do with brackets. So I'm just going to put in my open and close bracket. And actually, kind of interesting note, Visual Studio Code will automatically try and fill the closed version of whatever you open. So if I try and type in an open parenthesis here, it automatically puts that closed parenthesis. And it did the same thing with the bracket just now, open, close. And remember that Python strings are indexed beginning at 0. So this first dash is at 0, the second dash is at 1. That means I want to start at the number 2. So I'm going to go from 2 and then a colon to say 2 through. And I'm just going to count 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I want it to go through 12, but I need it to include 12. So I'm actually going to say 2 through 13, because in Python, that last number is not included. And if we run this, we should see hello world printed 3 times in this first statement, second statement, and third final statement. And there it is 3 times. Make sure again that you are not cutting off the D here by doing 2 through 12 because it does not include that last number. Final exercise. Let's print hello world converted to lowercase. So without just hard coding, as we would say, hello world in lowercase, we're going to, and I'll just get this part set up, create a variable called with the value of string hello world, where the H is capitalized and the W is capitalized. And I'm going to ask that you print out that converted to lowercase, and I will give you a minute to do such. So again, moving on in the interest of time, I'm going to use my print function one more time, and then I want to print out X, but I need it to be converted to lowercase. So I'm going to use that lower method on X, and remember it's a method, so the syntax would be to write X, my string object, dot lower, open parenthesis, close parenthesis, because methods always require these 2 parentheses, even if there's no input. And I'm going to save my code again. And now I should see hello world with the capital letters printed 3 times, and it printed a final time all in lowercase when I run this code. And there it is, 4 hello worlds, because this is programming and we just love the phrase hello world. All right, moving back to my slides. We're going to get into a new subject. Oops, I started from the beginning. Didn't want to do that. Yeah, okay, from here. All right, next topic. We're going to talk a little bit about numbers and math. Now, this should be a pretty quick subject, I would think, because, you know, it's pretty similar to a calculator, an advanced calculator, I might say. That's a lot of what programming is, but we will go through it real fast. So there's 2 main data types for numbers in Python. There's actually a lot other data types, but these are the 2 that you will most commonly see. There's integers and there's floats. So integers, as I'm sure you've learned in math class, are numbers that don't contain a decimal point after them. So it's just the full number and there will be no decimal. And floats are data types for the numbers that do contain a decimal. And my example here that I've included is 4.2, but note that like any whole number, so the number 4 would still be represented with a decimal as a float. So a float data type for the number 4 would actually write 4.0. And okay, this is my second and final slide on numbers and math. Like I said, pretty easy, fairly comparable to a calculator. I've put the sort of symbolic operations over here for each function that you might want to do. You know, if you want to add 2 numbers, just 1 plus the other, subtract 1 minus the other. The multiplication symbol is the asterisk. The divide symbol is the slash. The exponentiate is 2 stars. So if I wanted to say 2 to the power of 4, I would say 2 star star 4. And then there's this final operator called a modulo operator that I did not personally learn until I learned programming. Maybe you're learning them in math class now. But that is essentially the remainder from dividing 2 numbers. So if you recall back to lifelong division, when you would do things and you would get a result, you might say this is the result of dividing this by this with the remainder of that. The modulo is that remainder, and that can be pretty useful in programming later. I don't know if I can give a good example of it right now, but one that I can think of off the top of my head is wanting to know if a number is odd or even. You can do that with the modulo operator pretty easily. 1 second to There's also this concept of integer division, which I don't see mentioned too much anymore, but it's pretty cool. It's pretty much that rounded result that you would get when you're doing the long division and expecting to get a remainder. So I kind of walked through it right here. Normal division, we just use the divide symbol. And if we do 5 divided by 2, we get 2.5 expected. If we do integer division, which is this double slash here, 5 integer division by 2 will give us 2, because 2 goes into 5 2 times with the remainder of 1, and we're able to get that remainder with the modulo operator. I think that's it for numbers and math. But because that was so fast, I'm going to cover another subject before we dive into the next set of exercises. So, functions. What is a function? Sometimes you want to reference one particular piece of code multiple times, but with different inputs. So if I wanted to print out like the sum of 2 things, I might want a function that just returns that sum or prints that sum, whichever I'm looking to do. And I would be able to give it those different inputs. I wouldn't want to have to write out the code for it each time. And I kind of just said that with my original statement, but it takes in inputs, a function, and performs these actions with those inputs, and then it can return an output. It doesn't have to return a value. It can sometimes just do things, but you will see return statements quite a bit in functions. So, all right. The syntax of a function is listed here. We define a function with this value, keyword, def, space, and then whatever you want to call your function. So I wrote function name right here, open parenthesis, any inputs that go into it, close parenthesis, colon, and then your code block. And your code block has to be indented underneath that definition line. And the indentation in Python could be tabs, it could be indents, but you have to be consistent with whichever you use. I'm personally a tab person. I think that most Python programmers are, but it's a highly debated subject in the programming community, and whichever you want to use is fine. So here's some example functions that use the syntax that I mentioned before. Both take in 2 inputs, and note that the inputs are separated by commas. So I have input 1, comma, input 2 for those 2 different numbers. The first one performs an action by printing the sum of these 2 inputs and does not return any values. But the second uses a return statement and returns that sum. So because it gives a value back, we can store that value in a variable and use it later. So I wrote those 2 functions before, but that code, I'm just going to go back, that code won't actually do anything. You're just defining things, but you haven't actually called your functions. So in order to call them, you would simply write out whatever you named them here and then pass your inputs into it in the parentheses. So I'm calling the print sum function here, and I'm passing in the number 1 as input 1 and the number 2 as input 2. And we see that it's printing out the value of 3. This code obviously has the same result. We see the value 3 printed in the output, but instead of just printing the sum in the function, I'm returning that sum and storing it in the value of x. So it's giving me back this number that I can put in this variable and then print this variable. And while I'm just printing it here, I might have wanted to do something with it later. Maybe I wanted to pass that into a different function or add that to it. I wouldn't have been able to do anything if I had just used the print sum function. So that's why it's good to have a value returned. So there is a concept called default values that allow you to set a default for a particular input so it doesn't need to be included. And I created an example here, editing our return sum function from before, where the second input can be defaulted to the value of 0. So if you don't give me a second number, I'm going to assume that you wanted that number to be 0. And when I call it here and print out the output, I don't need to include that second input because it was given a default value. If I call this return sum on just the number 4, it only returns 4 because 4 plus 0 is 4. But that doesn't change the fact that I still can pass in a second value. So if I call return sum on 4 and 2, then it will return 6. All right, to the exercises. Okay, first one. Write a function that takes in a first name and a last name and prints the full name. I will give everyone a couple minutes for that. So I'll get started on that definition line to begin with. Remember that you start out your functions with the keyword def, and Visual Studio Code is changing the color for me, so I know that that's a keyword in Python. And then my function name, I can name it whatever you want, so you don't have to make yours the same as mine, but I'm going to call it full_name because it prints the full name. And then it needs to have its inputs defined. So that's done with parentheses and the inputs go in here. It takes in a first name. And these variables can also be called whatever you want. They don't have to be first name or last name. I'm just naming them such as that is what they are supposed to be. First name and a last name. I could call those X and Y if I wanted to. And then finally a colon. So that's the first line of defining our function. And then what you should notice is if you just press enter, Visual Studio Code should automatically try to indent this for you. It recognizes that you are making a function and that you need to have whatever you want to go in that function indented beneath it. So it will automatically do such. And I believe the default settings configure that to a tab, like this whole amount of space is equal to a tab for me. But you can change those pretty easily, I think, if you're a spaces person. So I'll just finish off the function now. Because we want to print the full name, I'm going to use my print statement. And the full name would be the first name plus the last name, except we need to include a space for Python. So I'm going to put an empty space there, just a string with a space in it. And then finally, the last name. And this exercise also helps us remember how we concatenate strings in Python. I could save this and run it, but like I said, we haven't actually called this function, so it wouldn't do anything in Python. This is just the definition, but it would be a good practice just to see if you have any errors in your code. Maybe you forgot the colon that goes after the definition name, and see, I try to save it and Visual Studio Code yells at me. But if I try to run it, I will also get the syntax error because I did not include that colon. So I'll add it back in. But we won't see any changes as we have not called that function. Okay, second, or I guess sixth technically, edit the function above to assume that the last name dough is the last name if given, or if none is given. Since we're editing that, I'm just going to copy to paste this function name while waiting for everyone to make that edit. All right, so in order to assume that the last name is dough, I'm going to take my last name input here and I'm going to say equals the string dough. So if you do not provide this with the last name, it will fill that one in automatically. And when I save here, because I know what Visual Studio Code is going to do, it's going to yell at me for this second function. This isn't actually an error per se, but it is noticing that I have two functions of the same name here. And that means that one will overwrite the other. If I were to call the function full name later in my code, it wouldn't necessarily know which one to do. I believe Python would default to using the first one that is defined, but typically it's very bad to have things that are named the same thing, just because you will get confused yourself. You don't know which one it's going to call. It implies that some mistake has been made and your code will not perform as expected later. So I'm actually going to name this one full name 2, and we see that little red underline disappears. Okay, number 7, write a function that takes in 2 numbers and returns their sum. So I'll just dive in. Again, we're going to start with the keyword def. I am going to name this function return sum, if I could spell return correctly. And we have our open parenthesis, close parenthesis for inputs. I'm just going to put the colon at the end for now, and then takes in 2 numbers. So I will call them num1 and num2 and enter. And I'll give everyone a minute to write down the return statement. Okay, so remember, returning something at the end of a function in Python is just the keyword return. And we want to return their sum, like I had said for the numbers and operations portion, num1 plus num2 is how we would get the sum of 2 numbers. And so that would return the sum of num1 and num2. Moving on to number 8, write a function that takes in 2 numbers and returns the remainder when dividing the first by the second. So again, our def keyword, I'm going to call this function mod, as that's sort of the nickname for the modulo function, which is what we will be using. And again, I'm going to pass in num1, num2, as there's 2 numbers, colon, enter. See that nice indent. And for my return statement, I want to return, parentheses, num1, the modulo operator, the percent sign, num2. And I'll save that. And again, because these are functions, we won't see anything actually change if we run our code. But number 9 calls the above function in order to get the remainder of dividing 233 by 8. So I'll give everyone a minute to do that. This is just a one-liner. I'm not asking anyone to write a function, just call a function. So that would be what we named our function, which I named mine mod, but whatever you named this function in number 8 should be correct. And then I want to get the remainder of dividing 233 by 8. So I'm going to pass in 233, and 8 is my second number. And this will just call that, but because it returns a value, I think I want to store that in a variable. Otherwise, it's just kind of returned and it's floating out there, not attached to anything. So I'm going to store that in the variable x, and I'm going to print x just so we can see it in our output and know that we've done something different. I will save that, and then I will run it. And we see that the remainder of dividing 233 by 8 is indeed 1. Okay, moving back to my slides, feel free to jump in with any questions. Let me know if I should speed up or slow down. All right, so Booleans and conditionals is our next topic. A Boolean is a data type that can have one of two values, true or false. Fairly simple. In Python, the syntax for true and false would not be in quotes. It's with a capital T, a lowercase f, and you should see the color changed in whatever ID that you're using. Like, you know, a true or false would relate to some sort of statement that we'll be making in a bit. And I think the next slide is on that. Now I just touched on the Boolean values, so I'm going to go into some of the comparison operators. So these are for comparing two different objects, and they will evaluate to one of those Booleans. So the ones that are really important to note here are the equal to and the not equal to. I think the rest of these are sort of what you would expect them to be: greater than or equal to, less than or equal to. But the equal to is a double equals, and that's pretty important to remember. I think a lot of beginners tend to forget and just do a singular equals. And remember, Python would interpret that as setting something equal to a value, not comparing them to see, are these two numbers equal? And then the not equal, I think it's less confusing, but just in general, that's an exclamation point and an equal sign in Python. So I have some examples that I ran in Python over here, printing whether 8 is greater than 3. It's pretty much asking, is 8 greater than 3? 8 is greater than 3, so that evaluates to the Boolean true. Then I'm trying to see if 6 is equal to 6. Remember, double equals here for the comparison. 6 is indeed equal to 6, and that evaluates to true. And then I'm evaluating if 6 is not equal to 6 using that exclamation equals operator, and 6 is equal to 6. So 6 not being equal to 6 is indeed false, which is what gets returned. And so the next slide is about combining different Boolean evaluations together. So in that last slide, we had an individual number being compared with a different number, and we could actually combine these statements in order to evaluate different Boolean expressions. So the ways that you can do that are with ands, ors, and not. Not is actually for a singular Boolean one. It just evaluates to the opposite of that statement. So not true is false, not false is true. Fairly self-explanatory. This is kind of the basis for all logic, but if you don't have that much practice with it, it can be a little tricky when you're getting started. So again, I think it's pretty straightforward. It evaluates to true if both statements are true. So if I have one Boolean statement, another Boolean statement, both of those need to be true in order for the full result to be true. And then or is the same thing, but it will evaluate to true if one or the other is true. And there's actually a truth table that I included, which kind of just iterates through all the possibilities here and shows you what they should evaluate to. Kind of what I just talked to, so thought it'd just be a good reference slide. Okay, so now let's get into conditionals and their syntax. So sometimes the whole reason for that Boolean comparison operator thing was because sometimes you only want to run a block of code if a particular condition is true. And so in Python, you know, we call that an if statement, pretty common in most programming languages. In Python, we just define an if statement with this keyword if, whatever your condition is, colon, and then the code block. And similarly to a function, it's ended on the line with that colon, and then the code block needs to be indented to determine what is inside that if statement. And I have a couple of examples here, so more concrete things. So we have an if statement that's comparing x to y, and it's saying if x is greater than y, print out x is greater than y. And then outside of that if statement, so the unindented bit, we're just printing outside of if statement. So in this example, x is 2 and y is 3. So we're only seeing what's outside of that if statement running. But note that it still does indeed run. In the second example, I've made y1, so x is greater than y, and we see that x is greater than y prints in addition to the outside the if statement print statement. So there's also a comment or a concept called an elif statement, and those are conditionals that follow the previous condition. So you could have an if statement and then a second if statement that you only want your program to look at if the first one was false. So I made a kind of trick if statement here that says, if x is greater than y, print x is greater than y. And then an elif, and I think I actually meant to change this print statement, pretend it says x is equal to y. Elif x is greater than or equal to y, it should print x is equal to y. And the reason why I did that is because it will only execute this second print statement if x is equal to y, because it checks this x is greater than y condition first, and it will skip this elif if that first if was true. I think I explained that a little confusingly, so let me know if you have any questions on it. And then finally, there is an else statement. Essentially, if the previous if statement was not true, or anything before it, you could have many elif statements before it was not true, then it will do that else statement. So anything that's within that else statement happens if the previous conditionals were not true. And I have this note about having an optional elif here. It doesn't need to be there. A valid syntax is to just have an if statement. You could have an if else statement, or you could have just an if elif statement, or you could do if elif else. So any combination, as long as it begins with an if and the else would be at the end, but it doesn't have to be at the end, is valid syntax in Python. I think that's it for conditionals. So let's go to the exercises. I only have one exercise for this particular topic. So write a function that is called can be president that takes in an age and tells you if you can be president. So I've sort of included some more concrete instructions here. If the age is less than 35, you should print out this statement, you are not old enough to be president. If the age is equal to 35, it should print out you are exactly old enough to be president. And if the age is greater than 35, it should print out you are eligible to be president. And I'll give everyone a few minutes for that. So I'm just going to get started on the function definition line up here. I said that, well, your function could really be called anything, but in the exercise, I requested that it be called can be president. So I'm going to get my def keyword, and I'm going to make the name can be president, open and close parentheses and the colon, and it needs to take in just one input, the age. So that is what I will put for this. Enter. And I'll wait for everyone to implement the conditionals. All right, so the first if statement, if age is less than 35, pretty easy condition right there, it should print out this statement here. I'm lazy, so I'm just going to copy and paste it directly. And this print is indented properly. Note that we've got an indentation with the if here, and then a second indentation that goes underneath that if statement. So the print is actually indented twice overall. And then I'm going to unindent, and then I want to do an elif to check if the age is equal, and I'm using double equal signs here, to 35. Indent, and I'm going to print out this second statement. And then finally, I'm just going to use an else statement, but because we're covering all the possible values for 35, you could also have an elif statement. You could also actually say elif age is greater than 35, colon, whatever. But I'm going to do else, colon, space, and print out this final statement. And that's the solution. Again, we're just writing a function, but we haven't called it, but I could technically just print out and call it beneath here, print out the result of can be president and pass in an age. I am 26, so I'm going to pass that in to see if I'm eligible. And it prints out you are not eligible to be president. Save this and return to the slides. Okay, so this next concept I just kind of want to talk about because I think it will become sort of important for your projects that you'll be doing or the next series in the Python for Data Science lecture where you'll be hearing about how you can use Python specifically for data science. Sometimes you want to reference other code that lives in different files and you can import it as a module. So if I wanted to import something previously that I had saved in a file titled mycode.py, missing parenthesis here, that really bothers me, I would say import mycode, and I don't include that extension name .py. Remember how when I run it in the terminal, I say Python and then do include the extension. When you're importing it as part of your code, you do not include it. And it needs to be in the same directory in order for you to reference it this simply. There are ways to reference ones that are in different directories, but sometimes that can be a little complex, and sometimes that varies for per version of Python that you have. So there's like a couple of different syntaxes that you can use for importing things. The basic one that I just mentioned is to import the actual file name, no file extension. And then when you want to reference a function from that, you have to include the file name or what you imported it as, and then that function. So I have the function mod in our exercises file. And if I just import exercises in a different file, then I would have to say exercises.mod in order to use that function. I can also, however, just import the mod function from exercises. And the syntax to do that is to say from exercises import mod. And then I would be able to call it without needing to first reference the exercises name. And then finally, if you want to import all of the functions or all of the variables that are in a different file, you can say from exercises import star. The star just means anything and everything, and I can still reference it. This function that we just named can be president without including the exercises preface. So like I said, I wanted to show you this because I think you will be using some libraries next week, or at least that's what I would do if I were teaching said course. And libraries are just collections of modules that other people have written for you. So there's some really great ones for doing some more complex math or dealing with different data objects, etc. You'll likely need to import those. So it's just a good idea to understand what you're doing when you use those import statements. And then really quickly, I want to show you that you can actually import things into the interactive terminal. I'm going back to VS Code here, and I'm going to open up the Python interpreter. Oh, I wish this were higher up on my screen. Oh, well. So what I can do is I can actually import this exercises file that we've been playing with and then call functions in the interpreter itself. So like I said, I can say import, spelled correctly. And it automatically runs everything there. So there's a lot of things that don't live in functions. I actually have no idea why it's printing that out. I'm going to comment this out because it's bothering me. But it runs everything that it did have before, and it will still allow you to reference these functions. These are just print statements, so it's not making a big deal, but if you had some other code running, it would automatically do that. So if you were setting certain variables to certain things or like fetching some data from somewhere, it would automatically do that when you import it. But like I said, I should be able to reference certain functions now. So I can say exercises.mod, And then I'm just going to pick some fun numbers here, like 2020, I don't know, 11. So I see that the value of doing our modular function on the numbers 2020 and 11 is 7. So remainder 7 for dividing 2020 by 11. I can also update that. So if I say from exercises, import, let's say can be president. So that successfully ran. And then I don't want to type that again, so I'm just going to copy it, and I'm going to say can be president, and we'll pass in the age 100 for fun, and see that that runs properly. So again, if you just want to kind of be in the interpreter playing around with things, maybe you wanted to write some functions and then play with them in your interpreter, that's how you would be able to import in there for use. So I'm going to exit this now with the quit, open parenthesis, close parenthesis, and I'm back to where I started. Okay, how's everyone doing? I know we've been going for almost an hour. Next topic, I think there's 2 more topics left, so bear with me. So next topic is lists. So far, we've covered data types, string, integer, and float. A list is a data type that holds an ordered collection of items. And those items can be of different data types themselves. So you could even have a list of lists. The syntax for a list is just an open bracket, your items separated by a comma, and a close bracket. And to make an empty list, you would just have an open and close bracket as shown here. Lists can also be indexed just as strings could, with a pretty similar syntax of referencing the index in brackets. I think I have a slide on that. Yeah, I also kind of like what I did here. I wish I had done that for my string slide. So if you're looking up information on indexes later, come to this slide. So just like strings, they're indexed at 0. So meaning the first element of that list is at the position 0. Indexing a list is just like indexing a string, where we take out the list, do an open bracket, the number that we want to reference, and then a close bracket. And you can have a range just as you would with the string here, and the syntax is exactly the same as well. So here we see we're getting the values that are at position 0 through 2, so that's separated by a colon, and that is also not going to include the one at position 2. So instead of returning a substring, this is returning a sublist, as we are indexing a list. So here's some helpful functions for lists. I don't know if I showed you this function, but it's actually also a function for strings. It's the length function, and it returns the length of the list. I did show you this function, I'm remembering now. If we do the length of the letters list, it's not working. I was trying to go back a slide, but it's not working. So just remember that our list was letters A, B, and C, and the length of that is 3, even though the final index in that is 2. And then a method here. So remember that there's a syntactical difference between methods and functions. There's an append method that will add a value onto the end of a list. And this actually edits the list that you call it on instead of returning a new list. So we see in the example here, I'm doing our list, which was letters, dot append, and this new value D. And then I'm printing out the original list, and it's added on D to that original list. So that can vary like per method. It's not necessarily a method thing. Remember our dot lower method for strings returned a new string. It just depends on the documentation for that particular method. Oh, I thought I had more here. Nope. All right, let's move on. Okay, so first exercise, make a list that contains the colors of the rainbow as strings and set it equal to a variable colors. I will give everyone just a minute to do that. Be pretty straightforward. I don't know what they have planned for you next week, but I would assume that you would do more with the data type lists, as it's a data science class, and data will come in many different data forms, but it's frequently a list of different things, or some type of list of different things. I think you'll be learning about another data structure as well, that's kind of similar to lists, called dictionaries. I was almost going to go into that today, but I heard that they were going to teach it to you later and said, I'll just wait. All right, so with that, I'm going to make my variable name colors, and I'm going to say equals, open bracket. Again, it autofills with the closed bracket. First color red, oops. And sometimes when it autofills, it will type over that because it's trying to guess whether or not you really wanted it to autofill. So that's what it just caught me with. Orange. Wow, spelling is not coming easily today. Yellow, next green. And then you don't have to have the exact same colors that I do. This is what I think of when I think of colors of the rainbow, but I know some people say indigo violet instead. All right, so now number 12, use indexing to print out only the first 3 colors. So I want you to print colors and then use indexing on that in order to get just the first 3. And I'll wait a minute for everyone to do that. Okay, so for indexing, we use brackets, kind of like how we do when we define a list, but because we've got the list directly next to the brackets here, Python knows that that is for indexing. And we want to go from the first element and get those first 3. So this is at index 1, this is at index 2, and yellow is at index, or I'm sorry, this is at index 0. Wow. This is at index 1. This is at index 2. And that's the last one that we want, but the final number won't be included. So I'm going to say 0 through 3. And I'm going to save that and rerun our code. And we see red, orange, yellow is printed out here. Finally, just to get comfortable using the append method, this one is to use the append method to add your favorite color to that list, even if it's already in that list. So my favorite color is purple, so I'll probably just add purple again. Okay, I'm hoping everyone was able to do it. So I'm just going to say colors, my list name, dot append, and then the string purple. And then just so we can see that that has been updated, print colors out again. Same variable because append edits the actual object. I will rerun my code. And we see the full list with purple twice here because I added purple to the list again. So I'm not sure if that was a little unclear with lists, but you can have duplicate values in it. Lists are also ordered, which I didn't really mention. You'll probably be covering a different data type next week in which they are not ordered, but nothing really ever changed order from us defining it to everything we did with it. Just an important thing to note. Probably won't be too much of an issue, but you might run into some issues with it next week. Okay, back to the slides. Okay, so sometimes you want to perform some action many times, either until a specific condition no longer holds, or perhaps you want to do something to a large set of data. So loops are what allow you to specify running this particular code block many times or until the conditions of that loop no longer hold. So I kind of created an example here, just in case you needed to conceptualize loops. Consider the concept of mailing out holiday letters. You have a stack of letters that each need to be stuffed into an envelope. And you want to perform the singular action many times on each letter in the pile. You want to do this until that pile is empty. So in this kind of loop that we've got going here, the condition is that we want to loop until it's empty. We want to take a letter, stuff the envelope, and repeat until the loop is empty, or until the pile is empty. So here's some sort of what I would call pseudocode. This would not actually run in Python because these are undefined things, but some pseudocode of what we just described. So we want to loop, and the actions that are involved in that loop are to take a letter, stuff the envelope, and keep doing that until there's no more letters in the pile. So there's a loop with a condition to stop the loop, and we would continue to take a letter and stuff an envelope until there's no more letters. So there's two types of loops, and this is pretty much in every language. First, we will talk about the while loop. While loops are based on a particular condition. So if you remember conditions that we covered in if statements, that's what while loops are based on as well. A while loop uses a condition like this to check each time before completing the code block beneath it. So if the condition is false, it will exit the loop. And if the condition continues to be true, it will continue to perform those tasks. And in our example of mailing holiday letters, we would say, while the letters pile is not empty, take a letter, stuff the envelope. Our loop would then exit when there are no more letters, as that was the condition that we set it with. And while I'm on this slide, I'm just going to say note the syntax for while loops. We have our while keyword followed by whatever the condition would be, and then a colon, and then the actions that we would perform would be indented similarly to conditionals or functions. If the condition of a while loop is never false, it will loop forever because it will never exit that loop. It's usually not something people intend because then your code will never stop. But if this accidentally happens to you, you can exit it by simply pressing Control-C. Frequently, if your program is running continuously, you're wondering why it's taking so long, you have hit an infinite loop. So now I'm going to walk through writing a more concrete example of what you might do in Python with a while loop. So say we just wanted to loop through this list letters and print out every single letter in the list. We're going to take this list letters, and we're going to create a variable called index that will change with each iteration of the loop. So it's going to tell us what point in the list we are, what position, what index we are at, and we're going to change it with each iteration. So this is kind of just the structure that I'm putting here while we walk through building the while loop. But because my goal is to print out the value at that position, I am getting the letter that is at that position by indexing my list. So saying letters of the index for the variable I've set and printing that out. And I've got my while structure here with the colon. I just need to fill in a condition here. But notice that we are referencing the index here, and we will need to change that index with each iteration of the loop. So I actually need to say index is equal to index plus 1 at the end of this code block in order to get that to be the next index before going on and checking the next iteration of the loop. So this will say, ideally, it will continue to say, add 1 to the index after printing the letter that is at that index. And we want to do this until a certain condition is met. So that condition is actually that the index needs to be less than the length of the list letters. So the length of the list letters is 3, remember, from our function evaluation for length. And we want to loop through and print out the value at that index until the index is 3. Because we added at the end here, that will happen on the last iteration. So this is the output that we see. And I've included a table if you're having some trouble kind of walking through, seeing the loop. We see that the index begins at 0. We check is index. This should be a less than sign. If the index is less than letters, that's true. So we move on. We print out this A, which is at that 0th position of letters. And then we add 1 to index. Now it's 1. So we go through again. Is it less than the length of letters? True. And then we print out the letter at that position, B. Then we add 1 to index, it becomes 2, and so forth. And on the final iteration, index is 3. When we add 1 to the index being 2 here, it goes and it checks, and index is not less than the value 3, the length of letters, and so it stops, it exits the loop. So when we had, when we wanted to move through every element of the list for while loops, we had to manage the value of the index, essentially say like, this is where I am in the list, make sure you add 1 to that each time. In a for loop, you wouldn't need to do that. For loops are designed specifically for stepping through either a range of numbers or a list. So we can literally write for element in a given list and then print that element. We don't have to manage the index because it is implied that we move on to the next one each time for Python. So in our example of mailing letters, instead of saying while the letters pile is not empty, for each letter in the pile, take the letter, stuff the envelope. And it will stop when the pile is empty anyways, because it will grab the last letter and know that there are no more left. So in the example of printing out every single letter in our list of letters, this is kind of what the for loop table would look like in comparison to the while loop table. We see that less is being managed on your end. So for iterating through a list, it's probably the most easy way to do such. Okay, so this is the final set of exercises. We're starting out with loops here. So the first one, given a list, write a function that prints every element in that list on a new line. So we kind of just did this exact example. I hope it doesn't take too long, but it will hopefully get you familiar with the syntax of doing such in Python. Okay, so I'm going to get started with our function definition, the def keyword for starting at the function, and I'm going to call this function print all elements. So I say given a list here, so the input will be a list, and I'm just going to call that LST. A quick note while I'm doing that, the reason why I don't want to call it list is because list is an actual data type in Python. And sometimes, depending on your version, the interpreter will confuse that with you trying to cast something to a new type. So it might get confused with the actual keyword list versus me saying, this is what I am calling my input. So I'm just going to call it LST. And the colon and enter. And I'll just wait a minute for people to get their loops written. Okay, so I'm going to use a for loop for this example. If you decided to go with the while loop, don't worry. The second question is to actually use the other kind of loop. And this is pretty much the example we just walked through. So hopefully it wasn't too difficult, but I am going to say for element in my input list, print that element. And I will save that. And because we're just defining a function, we won't actually see any changes. But for fun, I'm going to go into the Python interpreter. I am going to import our exercises file. And then I am going to call this function print all elements. And I will use our colors list that we made before. That should also be imported as it was a variable that was defined in this, and we imported the entire file. So I'm just going to say colors and hope that Python knows what I mean. Oh no. It's because I did not do exercises dot colors. And we see every single element, including purple 2 times as we added, as I added purple for a second time to my list colors, is printed out. So I'm going to exit this, and we can move on to our second loop. And this is just to do the exact same thing as number 14, except use the other kind of loop. So I used a for loop for this one. So I would use a while loop in number 15. And I will give everyone a minute to do that, although I will copy and paste this function definition. And I'm going to rename my while so it knows the difference. So remember that if you are iterating through a list in Python using a while loop, you will need to be tracking the index. So I am going to create the variable index, and we could call this anything. I'll call it IDX to just be different from the PowerPoint. And I'm going to set it to 0 because I want to start at the 0th position of my list. And then I want to say, while this index is less than the length of my list, print out the value at that position in the list, and then add 1 to my index. If I did not add 1 to my index, we would just have an infinite loop where it continues to display the first element of my list, and I would need to Control-C out of that. Before moving on to the final question, I want to note that this syntax here, adding 1 to a variable, can be written in a few different ways. I chose this method so you could see what was actually happening. It's the easiest one to interpret, but you will frequently see people a lot of the times when doing an incrementing thing, say plus equals 1. So that actually, this notation just means IDX equals IDX plus 1, but people will say plus equals 1. Save this. And if I just go into Python again, and I'm going to import exercises, and I want to run my new looping function. Just so you know, I was using the up arrow in order to get what some of my previous commands were in the interpreter. It works in both in the interpreter and in your regular Bash or DOS profile. Do this, and we see the same thing printed. So good news, this one runs exactly as the print all elements function, which is exactly what we wanted. So the final one involves taking in a list and making some changes to it and returning a new list with those changes. So write a function that takes in a list of integers as input and returns a new list with 1 added to each element in the input list. And we'll give everyone just a few minutes to do that. Okay, in the interest of time, I'm going to start making the solution. Since it's another function, we're going to use our def keyword, and I'm going to name my function add 1 to list. It takes in its own list, so I'm going to use that LST as the input again. And just a quick thing to note, I am using the same sort of input name here for each of these functions. That's because anything that you define as an input is only known inside that function itself. So the LST that is in here is different from the LST that is in here, as they are in separate functions. All right, so first I'm going to create a new empty list. I'm going to call it new list and set it equal to just open and close brackets. And this is going to be the new list that I end up returning. I am going to gradually build up this list by adding one to each element and adding it to this list. So then I'm going to iterate through the list that was given. I'm going to say for element in LST. And I want to add one to the element. So that would be element plus one. And then I want to append this to my new list. So I will say new list dot append element plus one. And it's going to take every element in our given list, add one, and then append it to the new list. And then finally, once I've done that with every single element in this list, I want to return my new list. Okay, so I will save that. And then I'm just going to call it in here so we can just run our code one more time how we were doing it before. I'm going to create a list just so we can see that this is working out. I'll just put like a bunch of random numbers in it for now. Make it of length 4, and I'm going to print out the value that is returned from this add one to list, passing in this list here. So when I run this, we see that our output, what was printed out, is 35, 3, 77, and 82, which is 1 plus each element in this list. And that is the last exercise. So with that, I will say thank you for joining. Feel free to reach out, email me with any questions that you might have, either Python or machine learning related. And yeah, anyone have any questions that they would like to go over now?
Thank you so much for taking the time and putting all this effort into your amazing slides. Like, I was following along the entire time and I just learned so much about Python, so thank you.
Good, I'm glad. It's really important to have a nice base knowledge, I'd say, for things. I took a programming course in high school that I didn't think I learned anything from. And then when I got to college, I said, wait a second, I know what all these things are. And it was really useful. So having that set base knowledge was very important for me. And I'm happy to provide it to anyone else. I did notice some errors as I was going through these slides. So I'm going to try and fix those errors, but I will post them in the Slack channel once they're fixed.
Okay, awesome. And I think I'm going to email the recording to everyone who registered. So even though like not many people were able to make it today, I'm 1000% sure everyone will be like interested in watching the recording. But thank you again.
Yeah, good to know. And if you are watching this on the recording, I'm not sure if you stopped it yet, but if you are watching this on the recording, you can also feel free to reach out to me with any questions. I'm always happy to answer. I only included my email, but I am on the Slack channel, so.
Okay, well, with that, I think we can probably wrap up for today. And yeah, if anyone has questions, definitely hit up the Slack. So I hope you have a great rest of the week. Okay, well.
Yeah, enjoy your holidays and winter vacation.
Yeah, you too. All right, bye everyone.